We are looking at inverses today, as I mentioned. We are going to look at square root functions that we've been talking about, and given two functions, we want to be able to determine if those two functions are inverses. So I want to remind you that inverse functions are functions like when we think of them graphically, for instance, okay, they are a reflection across the line y equals x. So what I like to do when I'm checking for inverses, we're going to check algebraically, but I'm also going to show you graphically for those of you who are more visual. Okay, if you graph your functions, they should reflect across this line y equals x. So I like to go ahead and just put that line y equals x as a dashed black line in my calculator, okay? And then I'll add my functions underneath and I'll check visually, if I were to fold it over this line, do they line up? Okay, would they, they're essentially a mirror image across this line of each other, okay? Now, algebraically, okay, by hand, when we're checking inverses or verifying inverses, we use compositions. Remember, a composition is when you put one function into another. So you take one equation and you plug it into another equation and you simplify. Now, when you do that with inverses, get my pen to pop up here. Yes. Okay, so when you do this with inverses, it always simplifies down to just x. Okay, so there's two blanks here because it does not matter take both. It does not matter which function you plug into which. Both ways it should work. So this says two functions, we're going to call them f and g, are inverse functions if and only if. So if I take the g function, g of x, and I plug it into the f function. So now g of x equation is the input in the f equation. If I do that and I simplify, it should come out to x. This should also happen if I take f of x and make it the input into the g function. That should also simplify down to x. Either way you do the composition should simplify down to x if they are inverses. Okay, if you do this composition and it does not simplify down to x, then they are not inverses of each other. Make sense so far? Okay. Here it just says inverse functions. Remember the notation that we use has that little -1 as a superscript up there. So f -1 of x. That's just how we would read f inverse of x, or the inverse of f of x. Okay, if you are not given the two functions and asked to verify, okay, you're just asked to find the inverse. Remember, we've gone through this process. To find the inverse, okay, we're going to replace f of x with y, and then we switch x and y, and then solve for y, and then rename it again, because originally we replaced f of x with y. Once we find the inverse, we replace that y with f inverse of x. Okay, we're actually not going to do this process today. We're going to focus on the verifying inverses process in today's notes and practice. Okay, so we're doing the compositions. So here, number 1, it says determine whether the pair of functions are inverse functions. Prove your answer algebraically. Okay, so that means composition. Okay, we're going to put f of x into g of x, or g of x into f of x. It should work both ways. So for this example, I'm going to do both. I'm going to try to color code here. So we'll call f of x. Here we'll make that one green. And then let's do blue for g of x. Okay, so the first thing I'm going to do is I'll have f be the outer function and g of x be the inner function. So what I'm doing here, I'm taking the g of x function, and you can see I'm plugging it. Why won't it let me highlight? Okay, well, maybe I'll just change my pen color then. We're taking the g of x function and we're plugging it in here inside the g function. So we're taking this and we're going to substitute it in here for x. So instead of x squared equals 8, or not equals 8, excuse me, plus 8, we're going to have the square root of x minus 8 squared plus 8. So you substitute g of x into the f of x function. Now we simplify. So here, this set of parentheses that's being squared, you can see that it is a square root being squared, and those are opposite operations that cancel each other. Okay, so we're left with simply x minus 8. Okay, now there's nothing else to simplify in there, so we can drop those parentheses. And then we've still got this plus 8 on the outside. Now when I continue to simplify this, the minus 8 and plus 8 eliminate, that's 0, and I'm left with simply x. So f of g of x equals x. That checks out. Okay, but it should work the other way as well. I should be able to have g as the outer function and plug f of x in. So g, now this is going to go opposite. I'm going to put the f of x function as the input inside the g function. So I'm going to take this expression and I'm going to plug it in here for x. So it would look like this. I would have the square root, and then instead of x, I'm going to plug something in here, and then I have the minus 8. Now what I'm plugging in is the entire f of x function, which is x squared plus 8. So now when I look to simplify this, there's nothing to do inside those parentheses. So those parentheses can drop. So it's simply the square root of x squared plus 8 minus 8. Well, look at that plus 8 and minus 8. That eliminates. So then I've got just the square root of x squared. And the square root and the square eliminate. So now I am simply left with x, which is what we wanted. So that checks out as well. So yes, we have verified that f of x and g of x here are indeed inverses. So it just says determine and prove algebraically. So I'm just going to say yes, they're inverses. My proof is the work that we just did. Okay, it checks out both ways. Both compositions. Oh, they had a checkbox over here for yes. Let's check it. Yeah. Feel okay about those? I don't know why number 2 is highlighted, but oh well. Let's give it a shot. We want to do the same thing. We want to verify, are these functions inverses? Okay, so I'm going to do the same thing. Pick a couple different colors. Here's my f of x function. Okay, that was not supposed to be blue. That again. Yeah, you need both of those. Yeah. All right. So f of x is the red, g of x is the purple. So let's try f as the outer function and see what happens. So we're taking g of x as the input. So we're going to take this entire expression here that is g of x, what g of x equals, and we're going to plug it in for x here. All right, so that is going to look like this. Have the square root, and then instead of x, I'm going to just put some parentheses there. Then we've got +4 on the inside and then +9 on the outside. Now in that parentheses, I'm plugging in this expression here, which is x plus 9 squared minus 4. Okay, so now let's go to simplify. So looking at this outer set of parentheses, okay, I don't need those here, so I actually can drop those. So I've got x plus 9 squared minus 4 plus 4, all under the radical, and then plus 9. Well, the minus 4 plus 4 are going to eliminate to 0. So now I've got it down to x plus 9 squared under the radical, plus 9 on the outside. So now here, the square and square root are going to eliminate. So that's going to just leave me with x plus 9. And then that is a plus 9 on the outside. Are the plus 9 and plus 9 going to eliminate? Are they going to cancel each other out? They're not, because they're both plus 9. So this simplifies to x plus 18, which I cannot take, excuse me, I cannot take any further. So no, these are not inverses because it doesn't simplify down to just x. It looked like it was getting close, but one of those signs on the 9s would have had to be different for those to be inverses. I don't have to check the other way. It doesn't matter if one works and one doesn't. They both have to work for them to be inverses. That property makes sense? How to check for inverses? Okay, so I'm just going to put a side note here of why we said no. It did not simplify to x, so they are not inverses. All right, let's flip it over then. So we've got one more on the back. I'm going to take a look at with y'all, and then y'all are going to have some chance to practice these. Okay, so let's start. No, it really doesn't matter what you start with. I'll just start with f as the outer function again. So let me highlight here. All right, so f of x is the outer function, so I'm plugging in g of x as the input. So what that's going to look like is 2 times the g of x function minus 6 under the radical. So now I'm going to substitute in that g of x function. I'm taking this whole g of x and plugging it in here for x. So that would be 2x squared plus 3. in those parentheses. So now simplify. All right, so nothing inside the parentheses I can do, but this 2 is butted up against it, meaning it's being multiplied. So I'm going to go ahead and distribute this 2. So that's going to become 4x squared plus 6. And we've still got that minus 6. So the plus 6 and minus 6 eliminate. That's good. So that leaves us with the square root of 4x squared. All right, so then that whittles down. We take the square root, we take the square root of both of those terms, of the 4 and the x squared. I don't know why I just wrote a 2 there, guys. I was getting ahead of the game. That is a 4. We take the square root and we get 2, and we take the square root of x squared and we get x, and that's it. So are they inverses? Did that whittle down to just x? No, it didn't. So they are not inverses. That's not just an x, so it's a nope. Okay, if you tried the other way, I'll just show you for the sake of your notes. If you put g as the outer function and plugged f in, we're doing f as the input here, it would have looked like this. You would have had 2, and then instead of x, we would be plugging in square root of 2x minus 6. Now there, what is being squared is the square root, so that would have canceled, but you still would have had 2 times 2x minus 6, and then plus 3, and you would have distributed here, gotten 4x minus 12 plus 3, so then that would have been 4x minus 9, which is again not x. So you can see both ways, it does not come out to just x. Okay, they should, both ways should come out to just x. They should come out to equal each other and just be x. So this doesn't work no matter which way you check. All right, so today is all about verifying inverses. This property up here that says both compositions should come out to x for them to be inverses. Now I do want to show you, I told you I would show you graphically what this looks like. So we talked about graphing square root functions the other day, and last unit we talked about graphing quadratics. Okay, because we know a square and a square root are inverse functions or opposite functions. So graphically, what that's going to look like, when I put the x squared plus 8, I'm going to see a parabola because this is a quadratic. Now, when I put the square root function over here, it's square root of x minus 8. I'm going to see a square root function. Let me change that color. Okay, so when I look at these two functions, they don't look exactly the same because the quadratic shows a full parabola and the square root, remember, it has an endpoint, not a vertex. And that's because when we do the solving and we take the square root, we're only taking the positive square root. There's no negative sign, plus or minus sign out here in front saying to do it both ways. Now, if I put a minus sign out in front of it, you would see the other half of that parabola. See how it shows up there? If I put a negative in front, I have the positive square root and the negative square root. Okay, but we don't do that. That red part is not actually part of the function, because if you did that, if you took that parabola and just turned it on its side like this, it's no longer a function. it fails the vertical line test. Okay, a vertical line would go through this twice. Okay, so that's why we don't have the graph of the negative portion of that. So you're actually only seeing, it looks like half a parabola on its side. Okay, that doesn't mean these aren't inverses. These are inverses. This just has the quadratic would have a restriction. But you can see if you were to fold on that line, okay, that this half of the parabola would definitely align with this square root function. Okay, if you were checking some and they were not inverses. So let's look at one of those examples that came out to not be true. So this was the square root of x plus 4, and then a plus 9, and then x plus 9 squared minus 4. Like you can quickly see, looking at that graphically, these are not inverses, okay? Half of that parabola would not fold over this line to become this. Does everybody see that? So if you're more visual, you can check them graphically and see if they look to be a reflection across this line, y equals x. Okay? So algebraically, you're doing composition. Graphically, they should be a reflection across that line. Any questions about these inverses? Okay, you have got a practice assignment, practicing inverses in Delta Math. If you have any additional assignments that you have not finished in Delta Math, they would still be showing up under the upcoming. So let me just get a sample student page for you. So here's a possibility of what you could be seeing. You should definitely, oh, well, hang on. Today's isn't showing up. Let me activate it. Oh, this is what you should be seeing. All right, so you see today's, the 14th, is inverse relationships. Okay, it's just 6 of the custom questions and then a few refreshing on, actually, I'm going to take that part out. It's just going to be the 6 custom inverse questions. I'm going to edit that because we'll do a mixed practice later this week and you'll get more practice with the other stuff. Just going to shorten this one up some. Okay. So now you've just got those 6 problems to answer. Some of them go together. For instance, number 1 here, it asks you to get the solutions for f of g of x and g of f of x. Notice it says to click on an additional solution to add a box. So right here where it says additional solution, you click there. Now you can type in both answers. So you're going to type in the answer for f of g of x, and then you're going to type in the answer for g of f of x. So you're going to do both compositions and get your solutions here. Okay, and then when you look at number 2, it's the same equations. It says from problem 1, are they inverses? So when you checked them, did it come out to be inverses, yes or no? Okay, so some of them go together like that. Okay, so it's really not even 6 problems. Some of them are just like part 1 and 2 of one problem. So a short assignment for today. If you still are seeing the assignment from yesterday or last Friday, then you can finish those up as well. The one from last Friday is due tonight by 11:59. So if that's still showing up and you want to do it first, because it's due tonight, that's fine. You've got 3 that are possibly past due. If they're not showing up here under past due, late credit available, that means you probably already finished them. They should be under the complete tab. Okay, but we're at a total of 6 assignments so far for this unit. Okay, so check the different tabs and make sure you're not missing something that you need to go back and finish. Okay, y'all have the rest of class to work on that, to practice versus or work on missing work.